Welcome back, everyone. It's time to actually dive in with Python and use object-oriented programming to create our own objects. In part one of this series of lectures, we're going to focus on the class keyword as well as creating attributes for our objects. Let's jump to a Jupyter Notebook and get started. All right, so let's start off by actually realizing what an object already looks like in Python. If I were to create my list, 1, 2, 3, I would be able to then call the variable my list, say dot, hit tab, and see a bunch of attributes and methods off of this object. And the same thing goes for a set. And we've seen how to create a set using mySet equal to, and then we have this set keyword. And then if I take a look at my set, I can do dot tab and see a bunch of attributes and methods. What we're going to do is see if we can create our own user-defined objects. And everything in Python is an object. So I could say, what is the type of my set? And it will report back that it's a set. And I can do the same thing for that list I just created. It reports back that it's a list. So let's explore how we can use the class keyword to create a user-defined object. So these are built-in objects. Let's use class, that's C-L-A-S-S, that's our keyword here for a user-defined object. The class is basically a blueprint that defines the nature of a future object. And from classes, we can then construct an instance of the object. And an instance is a specific object created from a particular class. So we're going to now create the simplest class possible. So I'm going to say sample. Notice how my class name is capitalized. So by convention, for classes, we follow camel casing, which is to say that every word here starts with a capital letter, unlike snake casing for variable names and function names where we had underscores. So by convention, we use capitalized names for classes. So we have class sample word, and I'm just going to say sample here, open close parentheses, colon, and then we'll say pass. So recall that the pass keyword basically just says don't do anything, and it's a placeholder there. If we didn't have it, we would get some sort of syntax error in the file. So instead we have pass, and that's it. We've just created our first class. And all it's doing is just saying, hey, you create a sample class, and that's it. There's nothing else there. So let's create an instance of the sample class. We'll say my sample is equal to, and then we call sample, open close parentheses. We don't pass in anything into it yet. Shift enter to run that. And if I check the type of my sample, you should see something that lets you know that it's a sample type. All right. So what we've done so far is we used the keyword class, created our own sample class. It doesn't really do anything. Then we created an instance of that class by saying the variable name is equal to an instance of sample. And then we can check my sample, and it says it's main.sample. Later on in a future lecture, we're going to discuss what this underscore underscore main underscore underscore keyword actually means. Basically, it's just letting you know that this particular instance of sample is connected to your main script here. All right, so that's the simplest class possible. It's not very useful though, because it doesn't have any attributes. So let's now see how we can create attributes. So inside of class here, I'm going to write 2 lines of code. I'm going to say def, just like we would for a function, except when it's inside of a class, we refer to this as a method. And this is a special method called the init method, which is going to be called upon whenever you actually create an instance of the class. And we always start off with the self keyword, which basically connects this method to the instance of the class, and it allows us to refer to itself. And then we pass in any attributes that we want the user to define. So for example, instead of calling our class sample, I'm going to say that it's a dog class. So dogs have attributes to them, and an attribute is a characteristic of an object. Later on, we'll discuss methods, which is an operation we can perform with the object, but for right now, we're focusing on attributes. So we may be thinking, well, what kind of attributes or characteristics do dogs have? Well, they have a breed. So something we may want to pass is the breed of the dog. And remember, when we had my set and my list, I could do dot tab and then see a bunch of options. Some of these are methods, some of these are attributes. What we're going to do now is try to create an attribute here so that when I create an instance of the dog class, I can hit dot and then see that breed pop up. So let me delete these lines because we won't need them anymore since the sample class won't be used. And then we will say self dot breed is equal to breed. And these 2 lines can be really confusing at first, since this is the first time we see the self keyword and we see the sort of like strange assignment. But I want to run this first and then break down what's happening in these two lines of code. So let's run this, and notice my indentation there. Everything's indented a little bit. And let's create a variable. I will say my dog is equal to an instance of the dog class. Now, if I don't pass anything, I will actually get an error. So you'll notice that we actually get an error when we run this with no positional arguments, because we are expecting the breed parameter. So what this Python is trying to say to us is, hey, when you create a dog, it's expecting you to pass in a parameter for breed. So let's do that. We're going to say breed of the dog is a lab. And now when we run this, we don't get an error, and I can check the type of this my dog variable, and it says, hey, you now have an instance of the dog class. And if I say my dog dot and then hit tab, I should be able to autocomplete breed. Now the reason breed autocompletes is because right now it's the only attribute. Later on when we add in more attributes, we'll see a drop-down list. But if I run this, it reports back, hey, this instance of the dog class called my dog, its breed is lab. So let's scroll back up here and break down what's going on. Init can basically be thought of as the constructor for a class, and it's going to be called automatically when you create an instance of the class. This self keyword, it represents the instance of the object itself, and actually most object-oriented languages pass this as a hidden parameter to the methods defined on an object. But Python, it doesn't do this. You have to declare it explicitly. And by convention, we use the word self here. Technically, you could write in any variable name you wanted, but you should definitely stick with self. That way other programmers, when they look at your code, it makes sense to them. Now, I want to focus on breed because I found it confusing when I was just beginning that you see breed here 3 times. You see breed, self.breed is equal to breed. And I want to show you something that's not going to be correct convention-wise, but will hopefully help you understand how breed is being worked into this entire object. So what happens is when you create an instance of the dog class, Python is going to call this init method, and it's going to use self in order to represent the instance of the object itself, and then it's going to expect you to pass in this argument, breed. And I'm going to call this my breed. And what happens is when you say my breed here, I can set my breed here, and then you assign the attribute equal to whatever this parameter was. By convention, these 3 have the same name, but I want to show you how changing the name will hopefully make this clear to you what the actual connection is when you pass in the parameter. So I'm going to rerun this. And if I take a look at dog and then do shift tab, and you can also call help on dog, you'll notice that it's expecting my breed to be passed in. So what happens is you pass in this variable for my breed, and then the next step is you take whatever variable was provided for my breed and then set it equal to the attribute .breed or self.breed, because this represents the instance of the object itself. So all we're doing when it comes to attributes, which again are characteristics of the object, later on we'll learn about methods, is we take in the argument. In this case, it's my breed, and we assign it using self.attribute name. So that's just the convention of what you're actually typing, self. And then you choose the attribute name. In this case, I'm calling it .breed. So let's run this again. Make sure you rerun this cell so we have my breed there. And then I can say my breed is equal to, let's say Sam's a husky now. I run this again. I still have a dog class, and if I take a look at my dog, if I hit tab, I only have breed. I don't have my breed available because my breed was just a parameter name we chose for the argument. So we said, oh, pass in the my breed argument, and I'm going to assign it to self.breed here. And I want to make this even more clear by saying breed is now my attribute. If I run this again, what happens is I pass in again my breed is husky, the type again stays dog, but if I say my dog tab, it's now my attribute, and it happens to be husky. So all we're doing here is you pass in the parameter or argument, and then it gets assigned to the attribute that you can later call on your object. However, by convention, you're just going to use the same parameter name for all three of these, which is why you end up seeing something like self.breed is equal to breed, and you pass in breed. This is confusing at first for beginners because they see breed in here 3 times, but you can tell that once you're familiar with object-oriented programming, it's just cleaner to have all 3 of these be the same term. That way you know what's being passed in and where it's being assigned. There's no real reason that they should all have those separate names. So right now, our dog only has a breed, but let's go ahead and give it more attributes. So what else could a dog have? Well, a dog could have a name. And maybe we can say, does the dog have spots or not? So we have a breed, name, and spots. So here we just say, create some more attributes. Self.name of the dog is equal to whatever name you pass in, and self.spots is equal to whatever you pass in for spots. And notice here, what I'm doing is I'm kind of expecting certain data types to be passed in. I expect breed to be a string, I expect name to be a string, and spots, the way I'm thinking about it, is actually going to be a Boolean. So let me have a comment here. I expect a Boolean, true or false, does the dog have spots or not? So hopefully you get the idea here that not every attribute you pass in is going to be a string, but it can be an integer, a floating point, it can be a list, it can be a lot of stuff. So I rerun this, and now let's take a look at what we need to define our dog. We need the breed of the dog, the name of the dog, and true or false, does it have spots? So we'll have the breed of the dog be a lab. We'll have the name of the dog be Sammy. And we'll have spots be false. Sammy doesn't have spots. So I run this. I run that again. I still have that dog class. But now when I say my dog and I hit tab, I see the options. I can see breed, name, and spots. So I can call these, check what the breed of that instance of the dog class is. I can check what the name of the dog is. And I can check, hey, does the dog have spots? And it'll tell me false. It doesn't have spots. One of the issues with Python being so flexible is that later on, when you're a programmer and expecting other people to use your classes, you're going to need to add in some documentation to let them know, hey, I'm expecting strings for breed, strings for name, and spots should be a Boolean. Because right now, I could say something like no spots, and Python's not going to complain here because I didn't do any sort of type check to make sure spots was a Boolean. So if I were to run this all again, there wouldn't be any error. Just when you say .spots, it would print out that string spots. Okay, so those are the very basics of attributes. We'll discuss better ways to have type control to make sure things like spots are Booleans later on in the course. But right now, what I really want to focus on is the basic idea that you use the class keyword, then with capitalized names, you define the name of your class, and the very first method in your class is going to be a special method called the init method. And this init method acts as a constructor, and we have this self keyword, which is a reference to the instance of the class. So that instance of the class is then going to have these dot attributes that you pass in based off what parameters you define up here. And by convention, the parameter name, the attribute name are the same, which means you will see it 3 times. Once when you pass it in, and then once here for the attribute, and once for the actual assignment call. Okay, those are the very basics of creating attributes. In the next lecture, we're going to discuss class object attributes, and then we'll move on to talking about methods. We'll see you there.